morning, good afternoon, or good evening. Welcome to Gautham IT Solutions or Gautham Digital Learning. Now, in previous session, we have understood the introduction to Linux, that how Linux came into the picture, what was the perspective of Linux, and where Linux is standing. Now, in this session, we are going to talk about architecture of Linux. Now, before we can start with Linux, or before we learn how to install Linux, understanding architecture is the most important part. So let's begin with. Now, in this webinar, we are going to understand the architecture of Unix or Linux, or we are going to learn about file system hierarchy. So these two topics we are going to cover in today's session. So let's begin with the architecture of Unix. See, the architecture of Unix looks like this, as you see on the right hand side. The innermost layer where all your commands will be executed is called as hardware. And hardware is controlled by kernels. And to communicate with kernel, we need shells. And to communicate with shells, we use certain commands, or we, the user, who will be accessing it. Now, to make it more understandable, let me use a simple paintbrush and explain you in the better way what exactly I meant to say about the architecture. See guys, all the commands that we run in the system, whether you are checking the date and time, or you're trying to store the data, or you're trying to play a video, or you're trying to play a music, whatever it might be, everything will be executed in the innermost layer of this architecture, which is called as hardware. Now, hardware is the innermost layer where all your commands will get executed, right? Now, how I'm telling that all commands will be executed on a hardware level? See guys, suppose you wanted to visit a website, google.com, gothamit.com, musab.com, whatever it might be. Now, when you want to reach out any website, you take a browser. In the browser, you type the address of the website. Now that browser, with the help of your network card, whether it is a wired network or wireless network, will try to communicate with that website. So what is a network card? Isn't it a hardware? Yes, maybe you wanted to store your data on a drive. You have created a file. Where would you store your file? Now, it can be your photograph, it can be your normal file, it can be any document. Where will you store? You'll store it in a hard drive. You'll store it in a pen drive. You'll store it in a CD drive. So what is that hard drive, pen drive, and CD drive? Don't you think that it is also a hardware? Yes, you wanted to play a music. When you run a audio file, music will be produced. And from where you listen that output? From the speakers. What is that speaker? That is also a hardware? Yes. So everything what we do in the system will actually be executed in hardware layer. So all the commands, all the tasks what we execute has to be executed on the hardware layer. Now, this hardware will be controlled by another very important component of the operating system, especially Unix operating system. We call it as kernel. Now, what is kernel? See, kernel is the boss of the operating system. Everything or anything we do in the system will actually be performed by kernel. Kernel is the heart of the operating system. Think like this: if kernel is alive, OS is alive. The moment kernel fails, OS also fails. Every type of management, file management, CPU management, memory management, device management, process management, everything is handled by kernel. You think you double click and browser get opens? No, you are giving instructions to kernel and kernel is opening the browser for you. You think you are playing the music? No, you are giving instructions to kernel and kernel is performing that task for you. So everything in the system is performed by kernel, even the hardware is handled by kernel itself. Now, the problem is we, the users, will come at the end of the architecture. Now, you can say utilities or you can say users. I'll simply call it user level. Reason is utilities are also used by user. Now, we, the user, comes at the end of the architecture, and now there is a communication gap. We understand only human level languages. We don't understand binary or system level language, isn't it? And kernel only works with system or binary language. It does not understand our languages. Now, there is a communication gap. We don't understand system language and system does not understand our language. It's like we Indians, suppose for example, I'm in India and I'm an Indian, right? I don't know how to speak Chinese, Spanish, or any other foreign language. Now, if some Chinese or Japanese or Spanish or French guy is with me, I don't know his language, he don't know my language. What would happen? Can we be able to communicate? It would be very tough. So here we need someone who can convert my language to system and system language to mine. And who is that? That layer is nothing but your shell. Now, shell is an interpreter that will convert user level language to system and system level language to user. Now, we understood one thing during our introduction class that OS is a translator or converter to convert user level language to system and system to user. Not the whole OS does that. In operating system, there is a specific component which is called as shell. Shell is responsible to convert user level language to system and system level language to user, right? So what we do, we take a shell and on the type of it, we will be writing some command. Now that command will be converted into binary and provided to kernel. For example, you wanted to see date and time. So you take a shell and you will type a command. Or before that, shells are generally two types, graphical shell and command line shell. Graphical shell is the shell what you're seeing right now on our screens, right? I'm using different graphics, colors, mouse cursor is moving here and there. That is nothing but your graphical shell. And same way, we have command line shell. Even in Windows, we have command line shell. This is called a command line shell. Now on this, when I run a command, for example, I'll run a command called dir. Something will happen. I'll say CLS, something will happen. I'll say date, something will happen. So what is happening over here? I'm trying to run some command and it is getting executed, right? So we have two types of command. Shells. We have command line shells and we have graphical shells. Now we'll talk more about the shells in the coming classes, but in this you understand that shell is an interpreter to convert something. Now how the work happens, that is really fascinating. Let me explain you how the work will happen. User will be accessing the shell. Now on the shell, user will write some command. Maybe just you have seen, I write date command. The moment I type date command, shell will analyze whether that command is valid to continue or not. If it is invalid, there and then you'll get an error message. If it is valid, then it will convert that user-friendly thing into binary and present it to kernel. Now, kernel will then understand, okay, the user is asking me to go and find out what is the date and time. Now, where is the date and time stored? The date and time is stored on a CMOS battery. If you open your laptop dome or your desktop dome, you'll see on motherboard there will be a small battery attached called CMOS battery that contains your date and time. So it would go to hardware and it would ask what's the date and time. So hardware will tell this is the date and time and kernel will revert it back to shell. In which language? In binary or system language. Now here shell will convert that incoming instructions into user-friendly English language, and we will understand what is the date and time. And all this procedure will happen in microsecond at a lightning speed. The moment you type it, within no time, all this process will take place. So this is the architecture how Linux or Unix will perform, right? Fine. Let's move ahead and let's understand more important thing. I hope by now you understand the architecture of kernel or architecture of Unix very well. Now let's move ahead and let's try to understand file system hierarchy. This is also very important. See, to understand how an operating system functions, you should know where and how the OS stores the data. Right. Even in Windows, if you just go, I'll take you into my laptop. Now, in my laptop, when you go to my computer, now, in my computer, if I go to C drive, you see there are lots of directories available. In this, you have Windows directory. When you go to Windows directory, you'll see many subdirectories. Each subdirectory will be holding something very important. Same way, in Unix or Linux, it also stores the data in different locations. So we need to understand very, very well that each directory has what importance, because tomorrow when we start working with Linux, you should be aware that which directory possess what and what is the significance of each directory. So what are we waiting for? Let's start. Linux uses single-rooted inverted tree-like file system. Now you need to understand this line. Let me explain you in a very simple way. What does this line means? Normally, guys, you might have seen a tree. If you look at the tree will be something like this. The top of the tree will come, the leaves and the branches will come at the top, and the roots of the tree will come at the bottom, isn't it? This is how normally a tree looks like. But Linux uses single-rooted inverted tree. Now let's understand. Now if you invert this tree, it would look like this. The branches, the leaves, everything will come at the bottom and the root will come at the top. So this is the meaning of that inverted tree, and it has how many roots? It says it has only single root. So Linux has a single root that comes at the top, and inside that root, the whole operating system will be there. So if you want to enter into Linux operating system or Unix operating system, you have to go through that single root that comes at the top. So root is at the top and the whole tree is at the bottom. So I hope you understood that concept now. Let's move on. So the first directory that we will face is that forward slash. So what do you mean by that forward slash? This is the top level directory. It is also called as the parent directory for all the other directories. That's the reason it is called as root directory. It is the main directory, the mother directory for the whole operating system. Like in Windows, I showed you there is a Windows folder that contains the entire operating system. So same way here also we have a mother directory that contains everything. So the whole Linux or Unix operating system will be situated in that forward slash. Now this forward slash is also called as the root directory, the topmost directory in which there will be many subdirectories that would be holding some important locations. So what are those subdirectories? Let us try to understand. Now, as we pass through the main gate, we will find out many important things inside it. So as you enter into forward slash, the next directory that you will find will be slash root. So everything will be present in that slash, and inside it you will find another directory with the name root. What is this root directory? Guys, in Linux or Unix, we have the most powerful user, which is called as root user. Like in Windows, you have administrator. Here we have a super user called root user, who is the topmost user who can do anything, who can do everything, whatever it might be available. So each user require their personal directory. Like sometimes when you work in offices, or you might seen in the colleges also, we have our personal lockers where we will store our stores. I will store our things. So in the same way, here also for root, there will be a mother directory, there will be a directory, a home directory, in which root can store its personal stuff. So in slash, the first directory that you will find is root, which contains root's personal stuff. Now, no other user in the system can go into this directory. It is the property of root, and only root can go inside it, and root can store its personal stuff. It's like, guys, you're working in an office and you see there will be some important employees like your bosses, your managers, the VP. They will be getting their personal cabin in which nobody is allowed to go in their absence, like that. So here also root is the boss of the system, and root will get a personal directory where only root can go and no other fellows can go. Like that, apart from root, I may have many other users in the system. It's not possible that only one user will be there in the system. We might have many users with anyone's name. Maybe we may have a John user, we may have a Ali user, we may have a Ram user, we may have a Steve user. So there might be many users in the system, and each user required their own home directory. Every user will be given their personal directory to store their personal stuff. So where are the home directories kept for all the normal users? See, all normal users' home directories are kept in slash home. For example, you have a user called Steve. So there will be a directory in home with the name Steve for Steve. Suppose you have a user called Raghu, so you will find slash home Raghu. Suppose you have a user called Musab, so you'll find a home directory slash home Musab. So that's the same way how these things will be working, right? For all the normal users, we have one mother directory in which you will find all the other subdirectories present inside it. And each fellow will have their own directory. So let us say that this is the mother directory, which is slash home, or let's call it just home. Inside home, you will find one subdirectory for all the users that you have in the system. One for Steve, one for John, one for Raghu, one for Ali. Like that, for every user we have, there will be a home directories created. Assume, guys, the same situation what I explained you. You have an office, and when we have a general staff, we cannot provide one room to each staff. So important persons will get their personal cabins, and all the other normal employees, they will sit in a big hall, right? And in that, cubicles will be there. So each cubicle will be dedicated for one employee. So same way, here we have one parent directory with the name called home, and inside it, one subdirectory or child directory to each employee or each user whose name we have created, right? Now, again, in these directories, two people cannot view the content of each other. Suppose I have a directory for Ali user and Ram user. So Ali cannot see Ram's content and Ram cannot see Ali's content. Only Ali is allowed to go into Ali's home directory and Ram is allowed to go only in Ram directory. But root is the super user, guys. Root can go anywhere, but normal users cannot see each other's directory. Right, let's move ahead and let's continue our discussion. Then you have another directory called boot. See, as the name itself is telling you, boot is a directory that contains important bootable files which is required to boot your system. Whenever you are trying to boot your system, at the time of booting, we require some important bootable scripts, some important bootable files. So those important bootable scripts, those important bootable files will be present in slash root. In fact, it also contains the kernel image that will be needed to boot your system. So all the bootable data that requires at the boot time will be kept in slash boot directory. Moving forward, we have one more directory called etc. Generally, etc stands for etc. Now here it contains all the configuration files that you have in the system. Now, first of all, what exactly is a configuration file? See, we have different things in the system. We have users, you have network, you have softwares, you have applications. Each of these components will have their own settings files. I'll give you a small example. I'll open a Google Chrome browser. You see, when I open this Google Chrome browser, I kept a black theme over here. I kept many bookmarks over here. I kept my Gmail sign in over here. Now, do you think that these are just randomly giving me the things? No, I made the changes, and in some file, all these settings are saved. So that file that stores the settings of most important things of your operating system is called as configuration files. Like you have user configuration file, you have password configuration files, you have network configuration files, you have software configuration files, so many application configuration files. All type of configuration files are stored in etc folder. Then moving forward, you have USR. See, when I say USR, some people pronounce it as user. There is nothing wrong in pronouncing user, but pronouncing it user sometimes give a wrong impression in your mind. When I say user, the first thing that comes in your mind is it might contain something related to user, isn't it? But believe me, there is nothing associated to the user in this file. It contains software that you install in your system. Basically, USR stands for Unix Shareable Resources. So it does not have anything related to user. It's the default directory where all your software will get installed. Like in Windows, you have program files. Any software you install will get installed in C, program files. So in Linux, you have USR, Unix Shareable Resources. So I better recommend you to call it USR instead of user. User might confuse others and ourselves also. So we are going to pronounce it USR, full form Unix Shareable Resources. Then you have another directory called OPT. OPT stands for optional directory. What optional and for whom it is optional? See, optional directory for USR. See guys, Unix or Linux is very organized operating system. It keeps everything in a very organized manner. For example, we have two types of software. The software that is associated to OS and the software that is not associated to OS, but they are very important for our operating system and for our functioning. For example, even in Windows, you might see we have Notepad, we have Paintbrush, we have Internet Explorer. These all comes with your operating system. Now, even though I have that, but for better functionality, I might use some third-party software like Google Chrome. Google Chrome, I think, is better than Internet Explorer. It is easy for me, so I'm using Google Chrome. Or I might be using Firefox. Or I might be using some third-party softwares like Notepad++, right? So there are many things what I'll be using. So all OS software, it can be kept in USR, and all third-party software can be installed in OPT to segregate and keep the things in a wonderful way. Moving forward, you have bin. Bin stands for binary files. See, all the commands, what we run in the system, they are called as binary files. Now, bin contains those commands that can be executed by everyone in the system. These are low-level commands. What do you mean by low-level commands? The commands that can be run by everyone. They are not administrative command. So here are the commands that can be run by each and every user, like checking the date, checking the content of the file, checking the hardware architecture of the system, right? And opening the browser. These are something which are very, very low level commands that can be executed by every user in the system. Then we have sbin. What do you mean by sbin? Sbin stands for super users binary file. See, super users binary files are those binary files that can only and only be executed by super user. Or you can say this is the administrative commands, the command that can only be executed by administrator, right? Like changing the network, shutting down the system, rebooting the system, installing the software. These are all the type of commands that can be executed by each and every, it cannot be executed by each and every user, rather it can only be executed by root or admin level user. Non-admins cannot even execute these kinds of commands. Moving forward, you have slash dev. See, slash dev contains the information about the devices that are connected, especially the hard drives, like you have hard drive, CD drive, pen drive, tape drive. So all those things will be stored in slash dev. It is very much similar to device manager. When you go to device manager in Windows, you'll find all the devices connected. So here also you have information about all the devices that are connected to your system. Then you have slash proc. See, slash proc contains all the ongoing process files. Anything, whatever you do in the system is called as a process. Even moving a cursor from one location to other is a process. And every process will have process ID. It will consume some amount of RAM. It will consume some amount of CPU and all that thing. So all the ongoing activities, processes information, CPU information, memory information, all that things will be stored in slash proc. Moving forward, we have few more directories like var. Var contains variable data like mails and logs. See, two users can exchange email. Suppose I have a user called John and Ali. Now, John wants to send a mail to Ali and Ali wants to send a mail to Ram. Now, each user requires mailbox. So where are the mailbox kept? It is kept in slash var. And also all the ongoing activities, like user tried to log in into the system. Login was successful, one log will be stored. Login failed, another log will be stored. Maybe some event occur. So what happened in that event? That event will get stored in the form of log files. So all the log files that we get by the operating system will store in slash var, right? Moving forward, you have TMP directory. TMP, it contains temporary storage. See, normally what happens is whenever you are doing a task, maybe you are running an application. So that application requires some temporary place to store some data till the application is running. Now, as soon as you close the application, that data will be removed. So for temporary period of time, we need a place to store some data. So that place where applications, software, and operating system can keep their data for a small period of time is TMP. We don't keep anything inside it. It is generally used by application, software, and operating system to store its data inside it, right? Moving forward, we have MNT. MNT is a default mount point for any partition. Now we have to first study what is file system, what is partition, and there we will understand what is MNT. Now in a simple way, you can just understand that MNT is a place where all hard disk, internal hard disk can be accessed. Suppose you have a laptop or a desktop, inside it you have a hard drive. Now if you want to see how many hard drives are there, how many partitions are there, you can go to MNT and you can access the data in your pen drive, not in the pen drive, in your hard drive and the partitions inside it. Now we also have removable media. See, sometimes we use internal drives and sometimes we use removable media. What is removable media? Like pen drive, CD drive, sometimes you connect and sometimes you remove. So if you have a removable devices connected to your system, removable devices can be accessed from slash media. Internal drives can be accessed from MNT and external drive can be accessed through slash media. Now the last directory what we are going to talk about is lib. Lib contains library files. See guys, we studied in our previous lecture that normally Unix and Linux kernel is designed on C language. Even the softwares what we use, they are designed in different languages like C language, Java, Python. Now each language has its own set of libraries. Without these library objects, it is very difficult for the software to function. So all set of programming libraries, whether it is Java, whether it is Python, whether it is C, C++, whatever it might be, all those libraries are going to get installed in lib. We are not going to directly deal with that, but any software, if it requires a library, that would be present in slash lib. When you are installing a software, some libraries will get installed and those libraries will be kept in slash lib. Now, very quickly, guys, we'll go back and we'll start again from the beginning of this file system hierarchy. The topmost directory is slash that contains everything inside your operating system. Slash root is the home directory for the boss of the system, root user, the topmost user, the super user, the administrative user. All normal users home directory will be created in slash home. How many other users you have other than root? Each user will have a home directory in slash home. Suppose you have a user called Musab, so you'll find slash home Musab. You have a user called Ravinder, so you'll be having slash home Ravinder. You have a user called John, so you'll find slash home John, like that. Then you have slash boot that contains bootable files, kernel images that is required to boot your operating system. You have etc that contains all the configuration files of the system, whether it is user config, network config, software config, or any other configuration in the system. USR, also pronounced as user, but better to pronounce it USR, which stands for Unix Shareable Resources. USR contains software. It's the default directory where all your software is installed, usually OS related or OS associated software. Then you have OPT. OPT is an optional directory that contains third-party softwares, right? Moving forward, we have bin that contains the command that can be executed by all normal users. Whatever normal users can be able to execute, that will available over there. It can be a date command, it can be listing the files, listing the directory, seeing the properties, opening the browser, all that. Now, xbin contains super users binary that contains the command that can only be executed by super user. It's the administrative commands, right? Like shutting down the system, restarting the system, installing the software, changing the network, like that. Slash dev contains all the devices information that is connected to your system. Proc contains all the ongoing processes information like Task Manager in Windows. /var contains variable data like mails of the users and events logs. TMP is a temporary place provided for software, application, and operating system to keep some temporary stuff for a short period of time and remove it whenever their work is over. MNT is a default location from where you can access internal drives connected to your system. The removable media, pen drive, CD drive, tape drive can be accessed through /media. And all the libraries that are required for your software to function properly will be kept in /lib. So these are the architecture and file system hierarchy of the Linux, which is really important for us to understand before we can actually go into Linux. Thank you very much, guys, for joining this session. I'll be seeing you in the next session of this series. Have a nice day. See you.